All right, so we're going to try out something pretty cool. We're basically going to build out a solar system, and in order to keep my mind straight, I've actually preloaded in the very first object. So you can see the A-frame library is linked. You can see that we've got an assets tag, which is new to us, but this is, you can kind of see how we preload in images, and we're going to give them a source based on the file path over here in our file tree, and then an ID that we can use to refer to them later. And then down here we've got all the code to actually make an item appear in our solar system. So check out what this looks like right now. We have the Earth with a picture of Earth wrapped around it. It's pretty cool, so let's show how this works. We're going to do the same thing for Mars, and the fastest, easiest way to do that is you can look up a Mars map. Is probably the easiest. You can also use the phrase skin, Mars skin, and that'll usually work pretty well. But if you look in images, you want to find one that basically looks like a rectangular projection of Mars. So like this one would work really, really well. I actually took the time before we started to make sure that I picked one that looked good to me. So I can go over here, and there it is. And I'm going to load it into Cloud9 just by dragging and dropping. So it's right here, it's in the same file path. If I wanted to, I could put them in an images folder, but I don't. So the source for this image, I'm not going to do it like that. Source for this image is mars.png, and the ID, let's give it Mars as the ID. It's really simple. So now we have this image loaded in and we can use it later. How do we use it, you ask? That is a great question. All right, so I'm going to put another sphere on the table. I give it the position of 0, 1, and -15. Now this is based on the Earth sphere, which you can kind of see down here. Don't pay too much attention to the entire code down here, but just this one piece. The position we gave this was 0, 1, and -10, so you know it's like 10 units pushed back into the screen. The next planet, Mars, Mercury, Venus, then comes Earth and Mars, is going to be a little bit further away from the sun, so I'm going to put it 15 positions back into the screen. So just a little bit further behind than Earth is. And then the last thing that we need to do is we need to tell it, hey, I want you to like load in this thing. So if we wanted to, we could give it some color properties, but instead we're just going to give it this source property, and then it will know to look up the asset that we loaded in based on the ID. So we're going to say go find the asset with an ID of Mars. And this actually should be enough to get this item on the page. So let's refresh and see what we've got. Yeah, there's Mars right there. So Mars is, as you can see, behind Earth, a little bit further back. Now, Earth is doing two things. It's spinning, but it's also revolving around the central point of this scene. And so we're going to do that in two steps. Now, if you want to add an animation to something, you simply, between the two tags, just like in HTML, you add the animation code. So the animation code in A-frame, you can look at the documentation, and I'll link it in the video description, is pretty simple. You tell it what type of animation it's giving using the attribute, and we're going to feed it rotation, and then you feed it a duration. Let's have Mars. I don't actually know how long a Mars day is relative to an Earth day. I think it's a little bit faster because I've read The Martian. So let's go with 1800. And this is in milliseconds, so this means it will spin every 1.8 seconds. And then the from and to attributes tell it how far it's going to rotate. So we're going to use 0, 0, and 0 as its original orientation. 2, and we're going to use 0, 360, and 0. So that means it's not rotating at all on the x-axis, it's not rotating at all on the z-axis, but the y-axis is going to go from 0 all the way to 360. If you run this like it is right now, a couple of things will happen, and one is it won't necessarily repeat in the way that you're expecting it to, so we're going to say repeat indefinite. Delay is also a property that you can give to it. We're going to have it not delay at all. And then this last piece is the most confusing. It's the most like mathematical, but there are various different types of easing. So let me actually run it without linear easing and see what that looks like. Let's refresh. Yeah, and it's naturally going to smooth from like stopped to stopped. So it accelerates, makes its full turn in the time we gave it, and then stops. That doesn't make a lot of sense for the way that planets actually operate, and so by giving it linear easing, that means it's going to not accelerate or decelerate at all. It's just going to immediately start moving at the speed it would require to get through this rotation in this amount of time. So linear is going to be really useful for us in terms of the movement of the planets because none of it involves much accelerating or decelerating, at least from our frame of reference. So, having added linear easing to the picture, we can see that now it's rotating in a much more normal way. Awesome. Let's jump back in here. This last part about revolution, I had originally thought, oh, I'll just like give another animation to this, but the attribute will be revolution, not rotation. It took me a long time to wrap my head around what really happens here, which is we wrap Mars in another invisible shell of a sphere, essentially representing its orbit around the sun. And so we will do that by taking this entire A sphere and indenting it. And we're going to put it inside an A entity. I'm going to move this closing tag down here. And then this entire A entity, we're going to wrap this in a similar animation. So like the sphere itself is rotating, but then it's inside this larger shell of a sphere, which is also rotating. And the planet Mars is like attached to the edge of the sphere. Because any entity that we don't feed a position to, by default, is going to be centered at 0, 0, 0. And so it will rotate around that center point. Let's go ahead and still explicitly feed it that starting position. And then we can code in this animation. Now, almost everything is going to be the same. We're still rotating 360 degrees. But the difference is instead of it being the rotation inside of the sphere, we're going to feed this animation as part of the entity. So it's outside of the sphere. We're not rotating the sphere. Instead, we're rotating the entity, the invisible shell, that contains the sphere. And then let's change the timing of it to, how long is a Mars year? I don't know. I should look that up. I will later, but for now, let's just go ahead and have it go every 7 seconds. And we do want it to go a full circle. We want it to repeat. We want it to move in smooth, linear fashion. So let's save that and see what this looks like. Yeah. And Earth should come around first because it's on a 5 second and then 7 seconds. Rad. We got it. All right. There you go. You now know how to use the asset library to load in specific skins for the primitives that you put on the scene, and you also know how to animate individual objects and how to animate shell entities that contain those smaller objects. Definitely read the documentation on this and see if you can get some other ideas. See what happens when you pass other values to the easing property besides linear, and good luck to you.